Good morning, students. Now we are doing mathematics of HS second year science and calculus we are going to do. First we have completed the continuity, the continuous of a function we have described, and yes, rules also, all the sum of this type of exercise we have done every sum. Then we have started the differential calculus exercise 5.2, that is chain rule. We have started, we have done so many sum. Now we will continue that exercise. And remember one thing, in this differential calculus, that rules, formula, rules to all of we know, and formula we have to learn, that is differentiation of x to the power n with respect to x, this type of things, differentiation of e to the power x is equal to e to the power x, all we have to learn, and we have to learn it nicely so that we can implement it in this exercise. In exercise 5.2, we have done up to question number, so far as my knowledge, we have done question number 6 we have completed. Now we will do question number 7. Question number 7 is like that. Exercise 5.2. Here they have asked to find d dx of 2 root over cot x square. We have to differentiate 2 root cot x square. When we get this type of sum, first you think 2, it is constant. You can able to take 2 outside. Then this is what root means, power is half. So think of that formula, differentiation of x to the power n with respect to x, it is n x to the power n minus 1. If we consider this is x, half as n, so of course this also we need same, x same, then x to the power n minus 1. So we have to replace this x by that cot x square. So we can use chain rule here, d cot x square to the power half d cot x square. Why I have written? Just to follow this thing. To make it neutralize, what we will do? We will write d cot x square dx. Now see, we know the formula of differentiation of cot x. It is what? Minus cosec square x. X same. So x square, you have to give it x square. Otherwise you cannot differentiate, because that both this thing should be same. Then dx square dx. See how I have written this one to get that concept x to the power n x. So cot x square we have written. To make it neutralize, we have written d cot x square again here. Cot x square, we know cot x with respect to x. So that square, I have written here x square. This dx square we have neutralized by dx square dx. Now formula. As we know, x to the power n with respect to x is n x to the power n minus 1. So here also we will write, it is half into cot x square half minus 1 n half x to the power cot x square to the power n minus 1 half minus 1. Cot x square, it will be minus cosec square x square, because x square, it will be x square. It is also with that formula, it will be what? Twice x, 2x to the power 2 minus 1. We can cancel these two. Minus twice x cosec square x square. This cot I have written twice x here. This I have written. Now see, half minus 1 is minus half. And power minus means it is on the denominator. So it will be what? 1 by half power means 4 x square. So see that answer, it is like that. It is what? That minus twice x cos x square x into 1 by cot x square. So this is our question number 2. So we have done this question number 2. We have question number 7. Now we will do question number 8. Question number 8 is like that. Cos root x. So this is our question number 8. What we have to do? Differentiation of cos root x. We are going to do this sum. How to do this one? Cos x. Differentiation of cos x, we know it is minus sin x. So of course, but as it is written root x, so we will write here root x. Why? Because we know the differentiation of cos x with respect to x. Whatever this, that should be here. So to neutralize this, we will do what? Dx root x by dx. Root x means what? Half. So see what we have written. Chain rule, this with respect to root x, then root x, that is x to the power half with respect to x. Our answer is minus sin root x. Because the differentiation of cos x with respect to x is minus x, so of course we will write it is what? Minus sin root x. X to the power half means what? Half x to the power half minus 1. Minus half, I will write. X to the power minus half means 1 by root x. So if I write, so this will be the answer of question number 8. So it is also using the chain rule we have done, and it is of that form. Now we will do question number 9. Question number 9, they said what? Prove that the function f given by fx equal to modulus x minus 1, x belongs to R, is not differentiable. So question number 9, fx is given as modulus x minus 1, and for x is equal to 1, we have to show it is not differentiable. Differentiable, just like multiplicable. Multiplicable means what? We can able to multiply. Divisible, if we can able to divide. Just like that, can we differentiate that one? For that, we have to remember one thing. fx is differentiable if LHD is equal to RHD. LHS left hand side, RHS right hand side, LHL left hand limit, RHL right hand limit. Just like that, LHD means left hand derivative, RHD means right hand derivative. So LHD is equal to RHD. Now what is LHD? LHD means limit h tends to 0, fx minus h minus fx by minus h. This is LHD form. And RHD what? Limit h tends to 0, fx plus h minus fx by h. Think of that one. Here all things same, only minus h, plus h, plus h. That you have to remember. This portion is LHD, that portion is RHD. If both the things are equal, then you can say fx is differentiable at x equal to f. But here x is equal to 1. So what will be the LHD? LHD will be equal to limit h tends to 0, f x minus h LHD our x to 1, so 1 minus h minus f1, as x is replaced by what? 1. We have what? That formula only for x equal to 1 by minus h is equal to limit h tends to 0. Now 1 minus h, this can be rewritten as x minus 1 if x greater than or equal to 1. This can be written as minus x minus 1 if x less than 1. This is the form. This is actually how we can get. It is the way of getting to break the modulus function. If modulus x minus 1 is there, then modulus x minus 1 we can write x minus 1. That is same thing if x is greater than or equal to 1, and minus x minus 1 it is f if x is less than 1. That is the rules of modulus. We have break this one according to that. So here you see that 1 minus h little less than 1. 1 minus h means h is a very small term, and 1 minus h, so it means it is very small term, less than 1. So if it is less than 1, value of fx is what? Minus x within inside bracket minus bracket x minus 1. So if it is x minus 1, if it is 1 minus h, it will be what? Minus 1 minus h minus 1. I again want to say 1 minus h means little less than 1. Here x is less than 1. First thing. So we will choose fx equal to this one. Then we need f1 minus h. If you put here 1 minus h, here also you have to put 1 minus h minus 1 minus h minus 1. I think it is clear to you. Now, if x is equal to 1, then fx will be what? X minus 1. But x is what? 1. So we will write what? 1 minus 1. I again want to repeat. What is the value of f1? f1 is what? X equal to 1. So here equal to sign is there. So of course fx will be what? X minus 1. As x is 1 here, if you put here 1, there also you have to put 1. So now it is clear, I think. So if you cancel, we get in numerator it is minus minus plus h, but denominator it is minus h. After cancellation, so we will get only minus 1. So limit h tends to 0 minus 1. So we get what? Answer is minus 1. So what is the value of left hand derivative? Left hand derivative here it is what? Only minus 1. Now if we do for right hand derivative, same thing we will do. Here right hand derivative we are going to do. So for that we need to change these things. So now you see, if we here we are going to do right hand derivative, x plus h, 1 plus h minus fx minus 1 divided by plus h. I have written, it is according to the rule. Now it is 1 plus h little greater than 1. H is a very small term, so of course it is greater than 1. So we will write this one. So what will be the value of this one? 1 plus h. So it is 1 plus h minus 1. I again want to repeat, 1 plus h means greater than 1. Here it is greater than 1. So fx will be this. But our x is what? 1 plus h. If we put here 1 plus h minus 1, I have written f1 just like done earlier. X minus 1 it will be 1. So it is 1 minus 1. So I think it is clear to you. Now h by h is what? 1. So limit of this one is 1. Earlier we got what? LHDS minus 1. Now we are getting RHDS plus 1. So both are not equal. They are LHD not equal to RHD. Because this one is minus 1, that one is plus 1. Both are not same. If same, then it is differentiable at that point. So here it is not same, so it is not differentiable. Therefore fx is not differentiable at x equal to 1. So we get the answer of this one. What? That fx is not differentiable at x equal to 1. Now we are going to do question number 10. You will find in question number 10, one thing is given, it is what? Integral function. What is integral function? Question I will read. Prove that the greatest integer function defined by fx equal to greatest integer function x greater than 0 less than 3 is not differentiable at x equal to 1 and x equal to 2. So 2 to sum there 1. It is what? Fx is not differentiable at x equal to 1, another sum not differentiable at x equal to 2. So we have to do both the sum here. I will show only one sum and you will do the other. Fx is given as here this symbol. This symbol means greatest integral function. And you have to prove what? Not differentiable at x equal to 1. So you have to check for x equal to 1. Now we have to say something about this integral function. If it is integer, suppose 0, then its value is same. If it is 1, then 1. If it is minus 1, then minus 1. That means if it is integer, what? X, it is inside this. If it is integer, its value remain same. But instead of this, suppose it is 0, little greater than 0, 0.4 or 0.7, then it is what? 0. Before 0.4, what integer is? 0, so we will put 0. 0.1, 0.2, 0.7, 0.9, everything you have to put 0. You will get value 0. For 1, suppose 1.7, little greater than 1 but less than 2. Your value will be what? 1. Suppose minus 1, little greater than minus 1, suppose if I take minus 1.8, then it will be what? Minus 2, because before that integer minus 2 is there. 2. If I put 2. Suppose 9, then it is 2. So this is the nature of greatest integer function. This definition already we have done in class 11. So now we are using this one. Now LHD. LHD we are going to find limit h tends to 0 f1 minus h minus f1 by minus h. With that formula I have written. What is that formula? X minus h minus fx by h. X is 1 here. Now think of this one integral function. 1 minus h, little less than 1. Which one is less than 1? This one. But it is what? Not less than 0. It is just less than 0. Then what is the value? 0. So you will get that value is 0. What concept we are using? This one. 1 deducted from 1, little less number. That is what? Something point something. So of course it is a number in between 0 and 1. So then it will be value what? 0. So this is 0. F1. If we put here 1, it is what? 1. Minus h. Minus minus cancel. 1 by h. It is what? H tends to 0. H tends to 0 means what? H is not 0. It is a very, very small term. So, of course, then we will get the value, it is what? A very big number, because as h approaches to 0, its reciprocal, it will be a very, very big number. So, we can write it as infinity. Infinity means a big number. So, this is our LHD. Now, we will go for RHD. Right hand derivative. Right hand derivative, we have the formula what? X plus h, 1 plus h minus fx this by h. So this is our right hand derivative. Then you see, if a very small term added with 1, its situation is like that 1 point something, then its value is what? 1. So we will write it as 1. f1, integral function of 1 is 1. So 1 minus 1 divided by h. So limit h tends to 0. 0 by h. 0 by any integer, any number other than 0 is 0. So 0 divided by a number is 0, so it is 0. So what we get? LHD, it was infinity, very big number. RHD, we found it is what? 0. So both are not equal. So what we can say? Here LHD not equal to RHD. Therefore, fx is not differentiable at x equal to 1. So we get what? That at x equal to 1, our fx is not able to differentiate at that point. So with that we completed our exercise 5.2. Now we will move for our next exercise. Next exercise, it is what? That is in exercise 5.3. They have asked to find the differentiation of y with respect to x. Here, one thing it is that you have to know one definition. It is what? Explicit and implicit function. Explicit means one function if it can be two variable if it is given. If one variable can be expressed in the terms of other, then it is explicit. If it cannot be able to express in form of others, then it is implicit function. So if we go through this one, that is here equation type it is given. In exercise this, it is given, first question is twice x plus thrice y is equal to sin x. It is given. What we have to find? We have to find the value of dy dx. So what to do? We have to differentiate both the side with respect to x. We have to differentiate both the side with respect to x. This is our procedure. Then, as we know, differentiation of u plus v with respect to x is, it is what? Du dx, dv dx. That is, we can break, ddx can enter into both the terms. So here also it will enter. So we can write d dx of twice x, d dx of thrice y. It is the rule. And differentiation of sin x with respect to x, formula is what? Cos x. It is the formula already I have given, and I think definitely you have learned that one. Then another thing, constant into a term of x. Then constant will come out of the differentiation. C come out from that differentiation. Here also 2, it will come out of the differentiation. It will be twice dx. 3, it will come out, it will be 3 dy. Now, what is dx dx? As we have learned, dx to the power n with respect to x is nx to the power n minus 1. So, if x to the power 1, if we consider 1 x to the power 1 minus 1. That is x to the power 0, so it is 1. So, this term, as I have found it is 1 thrice dy dx cos x. So, we get 3 dy dx is what? Cos x minus 2. Cos x minus 2 is our thrice dy dx. If we take 3 in this side, that will give our dy dx of that equation. And yes, we can able to find the value of dy dx where they have given in equation form, and we are able to do. Now we will do question number 2. Question number 2, also in that form they have given. Here it is, question is twice x plus thrice y is equal to sin y. Twice x plus thrice y is equal to sin y. This is our question. What we have to find? We have to find dy dx. So as usual, we will differentiate both the sides with respect to x. Here also we have to differentiate. This is the procedure. So what to do? We can use ddx in both the sides. Then as usual, this part we use this technique. So here d twice dx by dx plus d dx thrice y. I have just taken d dx inside. Now it is sin y. Our formula is what? Sin x with respect to x. Whatever here it is, that should be there also. So of course we have to use here chain rule. As it is y, you have to write here y. And to make it equilibrium, we have to write dy dx along with that. So that d dy will make it balance, we get same thing again. Here you see that constant into this, constant can come out of the differentiation. Here also constant can come out of the differentiation. And it is the rule, constant into any term, it is this. Now, dx dx, it is what? 1. So 2 into 1 is 1. Here we get thrice dy dx. Differentiation of sin x with respect to x is minus cos x. So y, so it will be what? Minus cos y dy dx. Now, what we will do? We will take this also in that side. Minus cos y dy dx minus thrice dy dx. I have taken this term also that side. Now, if we give a bracket, then it will be minus. If we take dy dx common, then it will be like that. Minus cos y plus 3 by minus cos y plus cos y this. So it will, so I think it is minus this one. So I will write cos y, no need. Cos y dy, sin y dy, it is what? Plus cos y. So no need of getting any minus, it is sorry. And this if you take, it will be minus 3 minus thrice dy dx. Then if you take, I repeat it again. Differentiation of sin y with respect to y is cos y, not minus. I have written it was wrong. Now thrice dy dx, I have taken this one and then taken dy dx common. Then what will be the dy dx? Dy dx, it is what? Twice cos y minus 3. So this is our question number 2. So we have done this one. It is little bit similar like earlier one. Just only one thing you have to think that sin y was there. Now we will do question number 3. Question number 3, it is given. Ax plus by square cos y. This is our question. Ax plus by square is equal to cos y. This is our question number 3. Process is similar. That is, what is our process? Process is we have to differentiate both the side with respect to x. We need dy dx, that's why. That is, we have to give d dx in both the side. That is our first technique. Then use of this formula. So of course d dx ax d dx dy square. Now just like earlier one, y it was, it is y. So what we have to do? We have to give here y. Then dy dx. It is what? Use of chain rule here we have done. And of course, without that we cannot differentiate it. Now Cu is Cu. C is constant here, A is constant, A can be taken outside. B is constant, we can take B outside. Now see, dx dx by dx, it is 1, so this is 1. Here it is with respect to what? Y square, but it is with respect to x. So what we have to do? We have to use chain rule here. I have used chain rule. dy square with respect to y, then dy dx. Here, differentiation of cos y is minus sin y dy dx. Differentiation of y square with respect to y, it will be what? Twice y. So we can write here dy square by dy is what? Twice y. What formula we will use? Dx to the power n, dx is what? Nx to the power n minus 1. So with that concept we can write it is what? Twice y. Now we will take this also and that side. Then it will be what? Minus sin y dy dx minus twice by, little arrangement I have done, then dy dx. So what I have done, we have taken all the dy dx term in one side and remaining term in other side. Then if we take minus common, then this will be what? Plus. If we take dy dx common, this will be that. Then what is dy dx? Of course it is a divided by minus sin y twice dy. So it is the formula of this one. It is minus a twice sin, minus a divided by sin y by twice by. So student, that much for today. I think you understood. So we end our class now.